Okay, looks like we are good. First of all, thanks everyone for joining on a Saturday morning. Uh, but I'm hoping that you'll have a good session today, and we can discuss some good insights on Azure Autoscale. Um, so as we are recording, I'll give my introduction as well. So I'm Omkar Kher. I've been working at Rapid Circle for the last 8 years, focusing mostly on Microsoft Azure, leading the innovation lab where we have been helping our enterprise customers with their cloud adoption journey with products like Lead DNA. But if you'd like to know more about it, my contacts will be displayed towards the end of this session and you can get in touch. But the focus for today, Azure Auto Scaling. So, without further ado, looking at before we discuss auto scaling, it's important to understand what the ultimate cloud pitch is, which is ability to scale to near unlimited computational power that is also on demand as you need it, and being able to build highly available infrastructure and also optimize your costs by paying for what you need or use. I believe most of us who are on this call today have worked with Azure in some capacity. So would already be able to identify this basic pitch that exists for any cloud service for that matter, not just Azure. Um, so auto scaling becomes central to all of these 3 points. If you're talking about uh, scale highly available services or optimizing costs, automatically scaling your service to your demands, automatically scaling tenfold of what your normal capacity is uh, when your demand rises. That's the ability that you get, and being able to optimize your costs as well, making sure that your cost exposure is only to the compute power or the storage that you're using. That's what Autoscale is offering you, and that's the reason why we'll discuss it today. Try to dive a little deeper and understand certain caveats, certain use cases that one must be aware when we're talking about Autoscale. So what's auto scaling? It's basically backed by metrics captured by Azure Monitor. There are other mechanisms that come into play as well, but if you work with auto scaling configurations, you will primarily work with metrics that would be captured by Azure Monitor. You have the ability to scale horizontally or vertically. That is, you can either get more machines or increase your machine size. I would like to keep this session a little interactive with the folks online. So, if I were to throw an example, let's see if somebody is able to connect whether it would be suitable to scale horizontally or vertically. So, if let's say we talk about something like a web service that's an HTTP API that's exposed on the public internet, offering a service, a file upload or a chat service that works on HTTP APIs. If you were to scale this service, how would you normally scale this? Do we have any thoughts on that? Anybody wants to speak up and suggest? Would it be suitable to scale horizontally or vertically? Pratik, you want to go?
Yeah, so it will be ideal to scale it vertically. Uh,
Why do you say vertically?
since a server is hosting a web service, so it will be wiser to have that server strength to maximum to be able to handle the.
Interesting perspective. But in fact, when we talk about HTTP services, it's ideal for them to scale horizontally. So let's take in picture be very clear about what's horizontal and what's vertical. Horizontal scaling is you are getting more machines, correct? And vertical scaling is increasing your machine size. If you are increasing your machine size, your your machine is certainly going to have some sort of downtime associated with it. And especially when you are working with HTTP workloads, it's much more ideal to scale horizontally so that you are not, your service does not have a downtime, firstly. And any HTTP call that's being processed by your machine is not terminated prematurely. Does that make sense?
Yeah.
So if I'm not wrong, I think I have a app service that I've deployed over here. Let's go there. And if we go to Autoscale somewhere here, we should be able to see this notification, instance count, and custom Autoscale. So this is the Autoscale control plane that Azure offers for an app service plan, where we are able to decide metrics or scale to specific instance counts. So you'll notice that we are only able to scale to instance count, in the sense that we are only scaling horizontally, not vertically, when it's auto scaling. Likely because it's with app service is a HTTP workload again. It works with HTTP workloads, so it's much more relevant for customers to be able to scale horizontally rather vertically. Scaling vertically, do we have any ideas on what? Pratik, is this clear before we proceed with something else?
Yeah. It's clear.
Yeah. And but now, do we have any thoughts on what sort of use case would be more suitable for vertical scaling?
Maybe if we are using some database for storing data.
In a way, still, I would say that that would still be a gray area, depending on what the uptime for your database would be. But not wrong. Certainly not wrong. That could be applicable. Vishal, you want to take?
Yeah, so I guess when we are talking about the vertical scaling, I think it will be suitable for the on-premise environment.
Yeah, so we're not talking, we're trying to pinpoint on a use case rather than where it's hosted. So could be on-premise, could be on the cloud, because even on-premise, your services could still be publicly accessible or might require a very low downtime or no downtime. So to make things easy, you would, sorry, there's somebody adding a point there. Sanket, go on.
Yeah. I think one example that I can think of vertical scaling can be a scenario where we require heavy computation, like data engineering operation, where the machine uh, machine requires to compute something, and the instance requires a heavy size, cluster size, something like that.
Yeah, that's a very appropriate example. So I'll make it simpler. I think Sanket, your use case is very valid, but something like batch processing. So even in data engineering, what you'd be doing is having asynchronous services that are spinning up, processing data. If they notice that there's a huge workload, then they would probably scale vertically and then spin up again and again try to process that. Things like Azure machine learning workspace also come to mind. So where you are processing, let's say you have built a service that that's going to process video, maybe do some OCR on a huge video file, or count the number of faces, or run some sort of analysis on a video, which would mostly be an in-memory operation. And depending on the resolution of the video or the length of the video, you might want to decide what sort of a machine should spin up and process that video without running into memory blocks and still respecting the time constraints, whatever time constraints that have been set on that processing operation. So that's where vertical scaling comes into picture. So that should clarify what's vertical scaling, what's horizontal scaling. And with that, you can build auto scale configurations that fit your application needs. So you want to add, you can create configurations, the screen that we are looking at over here. You can basically create configurations where, depending on the metrics that you're observing, minimum, maximum, you can set them, you can schedule scale operations as well. Depending on that, you can make sure your auto scale configurations reflect, and auto scale service is able to make sure that more instances are added based on how your application is operating. So we'll go into a bit more detail. So that's a quick glimpse at Azure Monitor, basically, because that's one of the key services that feeds the metrics for your auto scale to work. This is a non-exhaustive list of supported resources where Autoscale is available on Azure. You have virtual machines, you have web apps, you have API management service, Azure Data Explorer, Stream Analytics, machine learning, media services, service bus. There's Autoscale available on quite a lot of services, basically wherever you would find a need for autoscaling. What you'll notice is most serverless offerings would not really need autoscale unless you're using those services in a non-serverless mode. So you might see Cosmos DB present over here, which has a serverless mode, but still has autoscale if you're not running it in a serverless mode. And because the principle for serverless basically is that you do not care about what your infrastructure configuration looks like, because you are only paying for the service that you're using. So I just wanted to get that serverless bit clarified before we proceed. I've also tried to jot down the scale units and scale metrics that are applicable to these services. Again, this is a non-exhaustive list and it can be a little subjective in some areas. But scale units basically mean that how does that particular service scale? For virtual machines, for example, it could be instances, but for stream analytics, it's a streaming unit. For service bus, it's messaging units. For Cosmos DB, it's RUs per second. So also along with that, there's scale metrics, which can vary depending on the service that you're using. So that's just to give you an idea of what autoscaling would look like outside our conventional example of a virtual machine. Are we clear here so far? Any questions in between? Trying to take a look at the team's screen just to make sure that. Okay. No questions. If there's any questions, I would encourage you to drop them in the chat and we can address them as we make progress. So modes of operation for autoscaling, we already got a glimpse of it on the Azure portal. You can autoscale or you can scale manually, of course. There is time-based autoscaling. There's metric-based autoscaling. There's also notifications, and notifications is a very interesting feature, because what it allows you to do is send out email notifications. Sure, I think in some areas there's also support for SMS or phone call notifications. But webhooks, the ability to have webhooks under the autoscale configurations can be a very powerful feature for you to know when your service is for your infrastructure to notify any of your monitoring systems that your infrastructure is under stress. And this webhook could also be redirected to your own application for it to be self-aware of the stress that it is putting on the infrastructure to maybe take some intelligent decisions. And we'll see one interesting case study towards the end where we'll talk about using this sort of a methodology. The diagram over here is, of course, a hierarchy that's picked from Azure Docs. Azure Docs, again, is the ultimate source for all the information that you're seeing over here. So yeah, I think if you want to dive deeper, that's going to be a very good area to skim through. Looking at the Autoscale architecture, it's four important components that the Autoscale architecture has to, or the Autoscale design has to accommodate. There has to be a monitoring system, which is what the Azure infrastructure brings in with Azure Monitor, ability to monitor resource metrics, ability to monitor the time against which Autoscale can happen. There needs to be a decision-making logic. That's where the core Autoscale rule engine sits, where your Autoscale configurations or profiles reside, and it's able to iterate through those profiles and then decide how your Autoscale, if there is an Autoscale event that needs to happen. Based on which there's actions taken, so there has to be a scaling mechanism. So that's where the actions are taken, be it sending out an email, a webhook, or increasing or decreasing instance counts vertically, horizontally, whatever is needed. And ultimately, a testing, monitoring, and tuning process that's not part of the infrastructure, but that process has to be there to make sure that we are able to test this. What you're seeing on the right in the bottom is the automate section, where you can actually look at the third-party integration, or you can have your logic app function or automation runbook running based off a webhook that can react to auto-scaling events. So with that, I think we will start diving into some of the insights of auto-scaling that we have had while we explored this. Looks like there's a question. Sanket?
Yeah, Omkar, the last diagram that you showed. So, do you mean to say that when the auto scaling is configured, like for an app service plan, when we do the auto scaling and we set some metrics that maybe scale up or scale horizontally based on this metric, so it automatically creates actions and rules behind the scene?
No, it's not creating that automatically behind the scene. That is something that is already surfaced for the end user. So the rules is what you are setting. There's definitely a rule engine behind there, but those rules are something that you are setting.
Okay.
So when you create an autoscale profile, that rule engine is what is going to work against it. So it's the plumbing that's put in place, but you are responsible for what goes through it.
Okay. Makes sense, yeah.
Any other questions before we proceed to the next part? Looks like we are good here.
So this rules can also be basically same, like wherein if we want to increase, we can mention them, and same goes for downscaling as well.
Yes. That's actually a very important point, that it's not just about scaling up, but also about scaling down. If you're only scaling up, then you're basically, if you're only auto scaling up, then you are going to require manual intervention to control your costs. So scaling in is also part of this offering. And that's what we'll get to see over here. So what we'll try to look at is, I think conceptually, so far things are simple. What Autoscale does, you have a virtual machine or you have a web app, let's say, that's going through, that on a normal day has about 70% CPU utilization. And what you decide then is that if your web app starts stressing out, has about 90% CPU utilization, you want to scale out. You want to make sure that there's one more instance present, or maybe a couple more instances present, to share the workload, make sure that none of the API calls or none of the HTTP calls that are coming in are terminated, or nobody's running into a service unavailable error. So one fine day, there's a lot of traffic that's coming your way. You're trending on Twitter for some reason, and your service is getting a lot of hits, and you start noticing that there's 90% CPU utilization or maybe more. That is where Autoscale is going to get triggered and add some more instances. And this traffic is certainly going to fade out once whatever was causing this this exceptional traffic, whatever that event is, that fades out. Your traffic is also going to fade out, and that's where your scale in event is going to get triggered. You are going to start reducing your instances to cut down on unnecessary costs that you will be paying for. So that's what we want to study over here. So in the example that I'm giving you, are you able to picture, let's say you set a scale out threshold of 90%. So if your CPU utilization, average CPU utilization goes above 90%, you're going to scale out. You're going to have a couple more instances. To scale in, you might say that if the traffic falls, if the CPU utilization falls below 80%, then scale in, reduce the extra 2 instances. Does this sound reasonable? Does this sound like an Autoscale configuration that you would agree with? Any opinions here? Okay. Pratik is giving a thumbs up. So looks like we are good. And I don't see any concerns raised from the attendees over here. But here's what happens in practice. What you're looking at is a graph of average CPU utilization versus app service instances. The red line over here is the number of instances. You can see the number of instances on the right side of the screen, about here. So the red line over here is something that indicates number of instances. So we are seeing that by default, we are starting off at 2 instances. I think Sanket had posted something in the chat, which is close to reality. So that's what we'll be looking at. So let's start over here at 5:15 to 5:45. Things were going fine. The CPU utilization, well, up about 5:45, we started seeing that the CPU utilization is going upwards and crossing 90%. Which is where our Autoscale configuration would say that, hey, we got to scale out by 2 instances, and the number of instances increase over here. The effect of number of instances increasing means that our average CPU utilization is going to decrease inevitably, right? So that's what we see happening over here. And somewhere around 7:30, we see that the CPU utilization drops below 80%. So as this utilization drops below 80%, what's going to happen is the instance count is going to decrease, which is, it's going to say that looks like the system isn't under too much stress. Let's reduce those 2 instances. But if you do the math, reducing those 2 instances, cutting down from 4 to 2, is going to mean that the average 80% workload is now again shared with 2 instances, which again means that the average CPU utilization is going to spike up. So it spikes up again, actually goes a little bit above 100%, which is unrealistic, which is where you would expect then Autoscale to again react to it and scale up. And there we have, as Sanket mentions, that it's going to scale up and down continuously. And because the gap is really less between our thresholds, it's going to just keep switching between 4 instances and 2 instances, which is not an ideal situation. Is this point clear? Are we understanding the scenario that we are discussing?
Yeah.
Cool. Okay. So Azure has mechanisms to prevent this, which is called anti-flapping. These are anti-flapping measures that are put in. So what Azure does over here is, in reality, if you observe this on Azure, this is again the same graph that we are looking at for our average CPU utilization. But what will happen is Azure will not scale in over here in spite of the average CPU percentage falling below 80%. Azure will not scale in. It will continue to keep it at 4 instances for one simple reason, that you don't want to create a very unstable service with that scaling in and scaling out. It's not going to be efficient for Azure, and it's not going to be efficient for your application either. So that's simply not going to happen. So what this means is that you, as a administrator of your application, need to factor in this flapping situation. If you do not factor this in, your auto scale profile is basically ineffective. Especially your scale in profile is ineffective. So this is where we started experimenting a little bit, and there's a simple formula that we can come across to calculate the effect of scaling in. So what we are seeing is this nice tool called Desmos. I'm not sure how many of you have used this. Let me see. Able to probably opening browser instances in a screen that I'm not aware of. Okay, that's perfect. Desmos is basically a web application where you can build nice graphs, create formulas, and visualize them. And that is what we are going to do. So what we see over here is this link is accessible to you guys as well. So what I can do is I can post this link over here so that you can play around with this graph too. And what we are seeing is basically a blue plot which uses the following formula to calculate the resulting scale-in metric. Considering the current metric has reached scale-in threshold. So what we are calculating is if a scale-in happens at any point in time for whatever metric that is being observed, if a scale-in happens, what is going to be the resulting metric? So if we are looking at, so on the y-axis you have the metric being observed. So for now, hypothetically, you can consider this as average CPU percentage. That's what we are familiar with from our scenario. And the green line over here is the scale in threshold. Red line over here is scale out threshold. Scale in threshold is where once your metric reaches, Autoscale will try and scale in, reduce the number of instances, and red line is where it will try to, if it crosses, if your metric crosses this line, it's going to try and scale out. The blue line that we see is basically, let's say at 10 instances, we reach 80% CPU utilization, which is where scale in is going to happen. The resulting metric is going to be somewhere around 88%, something like that. Is this clear? Let me go to this graph, which is much more visible. I'm bringing a little bit of math on the screen, which can throw some people off. So I'm going to really look for feedback over here. If you think things are getting confusing, let's use this time to resolve that confusion. But if you're understanding, great, then I'm probably good for teaching math as well. So do let me know if you're following this. So what we have over here is one is a scaling unit, which means how many instances are we increasing and decreasing. For now, I've kept it the same. I've kept it simple. So we'll scale out by 1 instance and scale in by 1 instance as well. That is how it will be. This is our 80 is our threshold for scaling in, and 90 is our scale out threshold. And then we have a resulting metric. The formula for resulting metric is also pretty simple. So what we are looking at is the number of instances that we have on the x-axis multiplied by the scale in threshold, and we divide it by the number of instances minus s, which means number of instances that we are going to reduce. that's a simple calculation that we are doing over here. So let's take, for example, if the CPU utilization over here is 80% and we are at about 10 instances, 80 multiplied by 10 is 800. Ultimately, that 800 is going to get divided across 9 instances if we do scale in. So what is the resulting metric? So that is what we are calculating. And what you will notice over here is, until the point of 8 instances, this area, this is scary area, because at 5 instances, if you drop below 80%, your resulting scale-in metric is going to be 100%, which is going to be a scale-out situation again. So which basically means Azure is not going to perform scale-in over here. So this is an area with this graph you're easily able to identify wherever this blue line comes below the scale-out threshold is your safe zone. So this is your safe zone. Anything below 8 instances, you are not going to be in a good situation. So if you are applying a configuration like this, you would be better off if you normally operate with 8 instances and above. Is this making sense? X is the number of instances. So if you see below, that's the number of instances, and that's the average CPU utilization, or any metric for that matter. More than happy to repeat this one more time, but I'd like to understand from the attendees if we are being clear over here.
That X is number of instance at that point, and S is the scale unit by which it will scale up or scale down.
That's correct. That's correct. So you'll notice that if I increase this, the graph is also accessible to you, so you can play around with it as well. If I increase the number of instances that I can scale with, our range also changes over here. So once again, I'll repeat myself. So let's say you're able to see the number 10 over here, right? The text is visible?
Yeah.
Okay. So let's say we are at 10 instances. And at 10 instances, what we are trying to calculate is what will be the resulting metric for a scale-in operation. That's what we are trying to do. We are trying to calculate the effect of scaling in at any point in time. And when will scale-in happen? When the metric will approach the scale-in threshold. What's our scale-in threshold right now? 80%. So at 10 instances, if our scale-in threshold is 80%, which means and scale-in is happening, which basically means the metric is at 80% right now. What we are doing is multiplying 80 by 100, which gives us 800, and then we divide it by 9, because that's what the number of instances will be after scaling in. So we get an idea of how this metric will get distributed. So the number will change, right? If we are at average CPU utilization 80%, and we go from 10 instances to 9 instances, of course, our average CPU utilization is going to increase. It's never going to decrease. This blue line is never going to come below the green line. Making sense?
Yes.
Okay. Okay. If there's any questions, please, I encourage you to just point out and we can reiterate through that. So that's what we are calculating is the resulting metric for a scale-in event, and that's basically the formula for it. We're just calculating what the effect is going to be. And a similar effect can be seen on scale out as well. Now, the scale out effect is not very relevant in practice, but important to observe. Because for scaling out, Azure will always scale out, irrespective of whatever the situation is. There's no anti-flapping measure for scaling out, because you are scaling out, it's not going to hurt anyone. It's not going to hurt your application. You're not going to reach in an unstable state. The stability issue has been solved by covering on the scale in. But this particular, just flipping this formula, what we have done is just the same formula, but now we are calculating with increased instances to identify what happens if we scale out at a particular point. So that's all we are observing. I see there's a question. We always want our resultant metric after scaling in to be less than the scale out threshold. That's correct. That's correct. Let me go back to the previous slide. No harm iterating through that again. So yes, that's basically what it is, that we want our scale in, the resulting metric after scaling it, to be less than our scale out threshold. So anytime the blue line is below, the blue point is below the red point, we are good. All this above 8 instances, we are not in such a good shape. Sorry. So we do the same thing for scale out. Again, I'm going to go to this chart, and now we have a purple chart. So no, all of it is identical. The only thing is now we are operating against the scale out threshold. So at 10 instances, if we are at 90% CPU utilization and we scale out to 11 instances, what is the resulting metric going to look like? Which is going to be this. And this is always safe. So even at 5 instances, let's say, we do scale out, we drop at 75%, which is fine. This still gives us an idea that this is where a scale-in event would trigger in theory, but in practice, because as you are as anti-flapping measures, this is not going to happen. So this formula is just for indicating where flapping is going to happen. So this area is where flapping is going to occur. That's all that we are observing here. So this should be pretty straightforward. There's a question by Prateek. Current instance count and scaling instance amount cannot be same, right? So current instance count and scaling instance amount or count cannot be the same. It could very well be. Can you elaborate on this question, Prateek?
For scaling specifically, so since the x minus s is the formula that we are dividing by, so that can't be 0, right?
No, that can't be 0, of course.
Yeah.
Yeah. So there'll always be one instance. So if I were to be very, very mathematical, I would apply a limit over here saying that where s is always greater than x. Cool. So this is the effect of scaling in and scaling out. So this brings something in perspective. These charts will help us identify how our thresholds should actually be laid out. So we have to get into the balancing act. For allocated instances, what value should a metric reach to actually cause a scale in? That's what we have to calculate. So we calculate the effective scale in metric. What does the effective scale in metric mean? That what should be the average CPU utilization, for example, for any given scale out and scale in threshold, what should be the average CPU utilization for a scale in to actually happen? That's what we calculate. So again, there's a nice pretty graph that we can take a look at. So what we see over here is, again, S is 1. We have our thresholds set. We have a resulting scale in metric and scale out resultant metrics present. So this one's hidden right now, the purple line, to prevent confusion. And what we are trying to do is we are trying to find out what is the threshold. So we're basically doing scale out threshold -1, and we are multiplying it by the reduced instances as well. So what this orange line indicates to you is that at any point in time, so for 5 instances, if we have scaled out, let's say at 5 instances, we were above 90% CPU utilization, we scaled out to 5 instances, and the metric starts dropping. It's going to drop and drop through all this area, but there isn't going to be any scale in occurring until it reaches about 71%. So at 5 instances, unless we reach 71% CPU utilization, there isn't going to be a scale-in event happening. And this orange line keeps showing us the trend of where actually the scale-in is going to happen. So as long as you are able to define the range of your normal instances, so over here you can say that 10 and above instances is where you should actually be. for scaling to happen perfectly at 80%. So whatever thresholds that you have set, they are intersecting over here. So this is the region where you don't want to operate. You don't want to operate below 10 instances. If you're operating below 10 instances, this configuration isn't ideal for you. And as Sanket rightly pointed out, a simple ground rule for this is that you increase this range. The moment you increase this range, you are able to handle even a lower instance count. So especially if you're operating, let's say it's a very lightweight application, not facing too much traffic, and you usually operate with say 4 or 5 instances. This is how your auto scale threshold should look like. Does this make sense? Is this graph helpful? Any questions so far before we proceed? Because this is basically the conclusion of this particular section, that we want to figure out what the scale out and scale in threshold should be. These are the formulas that help you. The links to these graphs are present. I'm going to paste this one as well over here. So you can play around with it. Okay, looks like no questions so far.
Pankaj, I've just got one. It's not a question as such, but more like a request. So when talking about practical applications of what you had just shown, so let's say that if I'm an architect, then how can I make use of these equations or make use of these graphs to optimize my cost essentially? So when I say cost optimization, it directly relates to the number of instances, right? So for example, if I have limited budget, let's say 20,000 rupees per month or something like that. So that means that I cannot, so my scaling instances, the value of S would be, probably I would choose it to be 1 or maximum 2. So just walk, is it possible for you to walk through a scenario that, how can an architect think like and make use of this to find the right, like optimize the cost basically, so focusing more on cost side of things?
The math for that should be very straightforward with this, because when we say S, if you want to calculate your cost, you can just apply a multiplier to that S, which is the instance count, or whatever the value of X is. Even if you don't want to go through some more complex, the simpler approach would be just following what's on the X-axis. Whatever is on the X-axis is going to indicate the cost for you, and what your cost is going to look like for those instances. This is not going to be able to give you any trend in your cost, that if you're going to face what sort of billing you would be facing. That's not going to be clear with this, because what we are looking at is not an operation across time. So you're not looking at that across a month what's happening. Our X-axis is number of instances at any point in time. So you're only looking at instantaneous cost, and you're not looking at how's my monthly bill going to look like if I do something like this. That operation is going to be slightly more complex and is going to require a few more variables in your calculation. For example, and I'm thinking loud over here, if you are aware with these formulas, all you can do is be aware what your range of instances can be. If you want to keep your cost really low, let's take an example. You have a budget of $20,000 to spend in a month on your infrastructure. So you have to identify what is the size of your instance and the number of instances that you need in the first go, and then identify what is going to be the trend in your application usage, where scale out is going to occur. So once you have defined your base price, is it going to be 50% of the time you're going to spend more or what? So you can start considering something like you're going to have $10,000 on your base instances. That's going to be your base cost, and you keep that extra $10,000 as a buffer for your auto scale events, and then define an upper bound of how your auto scale is going to be. So the size of your instance and number of your instances is going to play a significant role here, along with the number of times you expect the scale out events happening. So to put it simply, Rohan, this is going to be a very small step for you to reflect on your budget. This is not going to do the end story for you. It's only going to give you the instantaneous cost, if at all you want to do that, which would be simple. It's a multiplier on this. Does that answer your question, or does this make sense?
Yes, definitely it does. Thanks.
Okay. Anyone else? Any thoughts on what Rohan had said? Anything that you'd like to add, or any other questions?
No, I think I was just thinking parallelly, again thinking out loud. Maybe another axis on the same graph, which will denote the price, and that formula of that will relate directly to what Omkar you mentioned, the instance multiplier to that.
Yeah.
So,
but that's however always going to be the instantaneous cost, in the sense that you'll be able to tell that at that point how much are you paying, but it is not going to reflect how your monthly bill is going to look like. If you're working against a budget, that number is not going to be very helpful unless you know that hey, I'm building a let's make life easy, right? By taking an example of a service that does monthly billing, which is going to be busy. Most of the time, people are downloading their bills, or the bill calculation and all of that is happening towards the end of the month or in the beginning of the month. So there's a very small window in which you are probably going to scale out. Otherwise, all you have to do as a service provider is make sure that you are able to cater to a very low traffic situation. So you may have like 2 or 3 instances running all the time, whereas during the peak time of a month end and beginning of the month, you would want to be able to scale by 10x. And if you know that trend, then the calculation is easy. Then you can project these instantaneous costs against your budget and see if you are still going to stay afloat. It's basically about finding your base cost that you're always going to incur on your service, and what's the buffer you want to keep for unpredictable traffic. But that is a complex topic. If you really want to get it right, there's a little bit of experimentation that is needed against your own use cases.
So, I think the budget will give an idea of how much maximum instances I could afford, and based on those number of instances, I could then plot down the
trend is important, Rohan. I keep emphasizing on the trend because the number of instances, about $20,000, you could say that I'm not well versed with the Azure pricing sheet, but let's say hypothetically you can say that 10 instances you can run for the whole month. But is your trend flat? Is your usage really flat? If there is unpredictability, you have to factor that in. So you have to keep a buffer, and you have to identify how much buffer you really need on top of your base price. So if your budget is $20,000, it would be unwise to just say, unless your trend is purely flat, that keep some sort of a buffer. Could be 30%, could be 50% of that cost, and only allocate certain instances to cover $10,000 to $15,000 on your basic instances, and then there's $5,000 on top lying for your auto scale events. How massive your auto scale events are going to be, that only you can decide depending on what you understand from your use case. So that's where the experimentation is important. I think the last case study that we'll look at, there might be some points in there for you as well to look. But before we proceed, I think we'll move on to the next phase. I've written a few articles around the same points that we saw, the same graphs I've actually picked up from my own blog. If you're interested, you can visit. I'll be sharing this slide deck, so you should be able to go through them if needed. So we'll quickly take a look at, there's 2 more case studies left, which should be pretty quick. I'm not sure how we are tracking on time. How much time do we have, Rohan?
We started a bit late, so I think we can have 5-10 minutes more.
Okay, then I'll have to pace through this one. So non-linear metrics. So not every metric is linear when you're observing. So we started with CPU, which can be very easy to spoiler. So which can be very easy to work against. But let's say that you have an application that is a memory intensive application. So there could still be a HTTP workload, but the operation that it does is memory intensive. And you decide that you want to scale depending on your memory utilization. So you're going to add 1 or 2 instances depending on. So far we talked about average CPU utilization. Now we'll deal with memory. So there's 2 instances. Again, the same configuration, 80-90%, let's say, ignore the flapping situation. If your memory utilization goes above 90%, you are going to scale out and have 1 more instance. And if your memory utilization drops below 80%, then that is when you're going to scale in. Any opinions or thoughts around this? How do you think? So if your memory utilization is say 90% at 2 instances, and there's a 3rd instance being added, what do you think the resulting metric would be? We know that simple calculation, right? For a resulting metric. Can anybody take a shot at what the resulting metric would look like when we are working with memory? Is everybody doing some math over here, or are we waiting for volunteers? Okay, let me try and bring this into perspective. So you're looking at 90% utilization for 2 instances. And with 3 instances, what's going to happen? So do you think this approach is correct, where we say 90% memory utilization, 2 instances, so we can make it 180 units for this? There's
yeah, if we're thinking in terms of calculation, it would be 180 by total 3 instances.
180 by 3 instances?
Yeah.
Sorry, I was reading. I thought there was a question coming in. I think some kids dropping off, which is fine. So we look at 2 instances, 90% utilization, 180. We are going to go to 3. So 3 divided by 180 is 60. 60% memory utilization. Does the math make sense? Anybody standing by me on this?
Yeah.
Pratik, you were saying something?
No, yeah, I said yes. So that.
Okay. So there's the catch. There's basically the catch. For others as well, there's maybe I'd like to hear from others as well. If anybody notices a catch over here. Okay. Anyways, let's see. So scaling with memory is tricky because horizontally scaling against memory metrics carries the margins of operating system usage as well. You are spinning up a 3rd instance. So the 3rd instance is going to bring its own operating system running for it. And the operating system itself is also going to have some memory utilization of its own. It applies on CPU as well, but the margin over there is real low as opposed to what we see with memory. With memory, that margin can be significant. Can be up to 50% usage for an instance, if especially you're working with small instances, which have like 1 GB memory, you could even have 50% operating system utilization. So that's the catch. Does this make sense to you? So when we make that math, that 180 divided by 2 multiply, so 180 divided by 3, it's not really 180 because the moment the 3rd instance is coming, that 180 is actually going to be around 210 and then divided by 3. Making sense? So every added instance continues to add its own OS memory consumption, and anti-flapping measures by Azure can prevent this scale-in by incorrectly distributing the load on resulting instances. So what ultimately happens is when we look at scale-in for memory, Azure starts thinking, because your memory utilization keeps on increasing per instance, Azure starts calculating against his anti-flapping measures, saying that his number is 210 right now. and has dropped, let's say it drops 200 from 210, and it still divides 200 by whatever the number of instances you'd be scaling down to. And unfortunately, if that number is above your scale out, it's not going to scale in. Whereas in practice, if it actually reduced that instance, the memory utilization for the operating system was also going to get wiped off. But Azure just keeps thinking that, hey, no, this is not going to work out. If we reduce the this instances over here, the memory utilization trend right now is not going to the new set of instances are not going to be able to support this. So what I'll do is I'm going to unfortunately have to pace through this a little bit. I'm going to share this link and take you through the graph as well. So what we are looking at here is the base operating system utilization against across whatever the instance count is, and the red zone over here. So we have again the number of instances that we are scaling with. So we are saying over here that 30% memory is utilized by the operating system, and current memory utilization you can increase what your application memory utilization looks like. And what we see over here is the resulting memory utilization considering OS memory footprint. So this is what we calculate, and this should help you visualize exactly what range of instances is going to where Azure might continue adding instances to your infrastructure rather than reducing anything. So you want to make sure that your instance, this base, is really low, so that you are base operating memory usage, the percentage is really low, so that you are able to comfortably identify scale and events. Is the problem statement clear to everyone over here? At least the problem statement before we go any further. Cool. I think I'll also cover one more case before, and unless we have any detailed questions, so this will come back. But the Cosmos DB one is a bit more interesting, so I'm tempted to go there quickly before we can revisit memory if there are any questions here. But I'm dropping the link to the graph. You can play around with it and get an idea. There's also a blog that's written on this. There's a couple actually, where the challenges for memory-based metrics and everything are detailed out. Oops, looks like I pasted something wrong here. But anyways, we'll quickly take a look at respecting scale parameters, which is where we'll talk about Cosmos DB. So Cosmos DB works with scales. Either you can do manual scaling, you can do auto scale on top of it, you can do serverless as well. Hold on a second. Oh God. Sorry guys, I think something's wrong with my deck. I'm not able to move ahead, which is weird. Yeah. So coming back, so there's manuals. You can scale manually, where the minimum value can be about 400 RUs, and the cost that you face with the minimum RUs for Cosmos DB which can cost you between $18 to $25, I think. You can also auto scale, sorry. And in the auto scale mode, you can scale up to 10 times. So Cosmos DB has a limit that whatever auto scale configuration you put, it will always be in the range of 10x. So if you say that at peak hour you will need 20,000 RUs, at any normal time, Cosmos DB will always reserve 2,000 RUs for you. There's also serverless mode, where you even a few million RUs can cost about $1. But it is something that is not recommended for production scenarios by Azure. And for the serverless offering, the maximum storage is also blocked at 50 GB. Last I checked. So that's basically the description of of scaling on Cosmos DB. So we'll focus on auto scale. With auto scaling on Cosmos DB, as I mentioned, the range can be 10x. So let's say 10,000 RUs. The minimum that you will have to pay for is 1,000 RUs. While Cosmos DB can take care of scaling automatically depending on the requests that are coming in. You don't really have to put in a profile or anything as such. This is the only one number that you have to commit on. But what's useful here is that Cosmos DB provides an API that the Cosmos DB API provides the RUs consumed for every query that you send in the HTTP response header, which is useful because RUs are not predictable. It's very difficult to say depending on the read. So for a single read operation, for 1 KB, I think it's 1 RU that it takes, but depending on the complexity of your query, the RUs will change. And they are not very predictable. You can learn about your own RU consumption depending on your query, what the query pattern really is. So what's helpful is the API provides you very transparently that, hey, this query that you sent, here's the response, and these are the RUs that were consumed in this. Azure also provides an API to control the autoscale configurations for Cosmos DB. And you can implement code that is aware of the scale parameters and control them if needed. So I've provided a link to a GitHub repo over here and a case study. I'll share these links as well, would be accessible to you once I share the deck, which is created by the team at Allegro. What this does is this is basically C# code that will be able to be aware of the limitations of your Cosmos DB scale, whatever scale is configured on Cosmos DB. It can calculate the RUs that are being consumed through every Cosmos DB query and make sure that there is throttling done on the code itself to prevent that scale parameter from being breached, because otherwise you're going to run into service unavailable error. And it can also proactively scale Cosmos DB as needed. So whenever it thinks that there is a query or there's workload that is going to come up that is going to definitely require changes in the auto scale threshold. So let's say you normally operated on 1000 RUs. So your base RUs would be 100 and range between 100 to 1000. At some point, if your application has heavy processing going on, you can use this utility to just change the scale parameter, increase it to 20,000 RUs if needed, and work with that. So that's something that's also possible with Cosmos DB. So it's what I wanted to highlight over here is that you're able to respect your code can be aware of your infrastructure scale limitations as well. It's important for the code to be aware. The code need not only be responsible for stressing on your infrastructure, but also being aware of when it is stressing too much and then throttle itself a little bit. Wait for the infra to cool down and then continue with what it intends to do. Pretty interesting use case in my opinion. So that's basically the last part. I'll quickly highlight a few guidelines. A lot of these, there's a very detailed write-up over here. I was intending to create some guidelines on this text, but I think Azure Docs does a far better job. But I'll still highlight one small section out of it, that autoscale processes only one profile at a time. So if a condition is not met, it checks the next profile. So that's important for everyone to know, anybody creating an autoscale configuration, that it's one profile at a time. The default profile is always checked last. So any important metrics that you have should not be kept in the default profile, keep it in other profiles. So that the default profile gets checked last, and if nothing really meets the criteria, then default profile is going to kick in. Your scale out occurs if one rule is met. Any rule in your profile that meets for scale out, it will scale out. But for scale in, all the rules have to be met, which is where the anti-flapping measures also come into play. So that's something for you to keep in mind, and that's basically what we have for today. If there are questions, this will be a good time to discuss. Otherwise, we can conclude.
Omkar, I have a question about
Well,
memory scaling. So, is there a way of knowing how much is the operating system memory usage? Is it part of some documentation, or is it something that we have to find out on our own?
unfortunately, no, because that is very difficult to predict in itself.
Right.
Your operating system memory usage can vary depending on the nature of your application. It's not a you can have ballparks, but what's always recommended is, I think one important guideline that I should have laid out is the fact that through your app insight logs, you should be able to monitor these trends for yourself. For your own application, you need to be aware. So there's a good amount of profiling that needs to happen on any application that is going to run on your Azure infrastructure. So that profiling should give you all of these insights of what, for your particular application, what is the operating system memory utilization going to be? What is your application's memory utilization going to be? Forget the operating system. If you know your operating system's memory utilization, you will be able to do the simple math of subtracting out from your total memory utilization and identifying whatever the overhead is. It need not be just operating system, but other complementary services that are working for your application. So that's something that's needed, and that's not just for memory. That's needed for CPU as well. That's needed for any metric for that matter. Be it even the number of sockets that you're using. We have seen cases where we have had to put auto scale configurations on the number of sockets because we had built services that used to communicate a lot across each other. At times, about 20,000 calls in 10 seconds or so. And that used to lead socket outbound errors. We used to exhaust the number of sockets that would be available. Now, if you are, and this is an outlier, right? This is an application specific thing. We would not figure this out unless we understood our own service better. So that exercise, I think, is important for every application developer, every Azure application developer, to understand that there's an infrastructure that they're working with, and there's metrics that can be observed. All kinds of metrics that can be observed need to be observed, and then you take a decision based on that. Identify if there are spikes, wherever you are hitting limits in some very odd metrics as well. Just cover for them. But yeah, that's basically it. Alok.
Hey Omkar, just one question. Isn't there a setting like a time window which we can set, saying that if this threshold is passed and it stays that way for this time window, trigger scale out only then, or triggers scaling only then? So if my CPU percentage goes above 90%, but it was
Azure by default takes that time. Azure, it's one of the guidelines that Azure provides, that your auto scale event, you can't configure that time window. To answer your question very clearly, you can't configure that time window, but there is a time window that Azure itself uses, which can span between 5 minutes to 15 minutes. So auto scale is not good for burst of traffic. If you have like suddenly in a single second you were running on 2 instances happily for and catering to maybe 10 requests per minute, and suddenly within a single minute you start receiving a million requests, and you're expecting auto scale to cater to that by scaling up for in that burst. That's not going to happen. If you think you face those bursts, then you'll have to become good at predicting those. So the time window is not something that you can configure for in between autoscale. I think Sudarshan is pointing out something. The scale out for a time window is available, which is manual. Sudarshan, can you elaborate on this?
So this is a setting wherein like you can have just increase the instances in that particular time window. So it just and it is a manual producer because
Scheduled.
there's no that is just a scheduled scale out.
Yeah. So if you know, so the point that we talked about, right? I think we talked about one case where we're doing billing. I like that use case very much because it's the most easiest use case to handle. That you're billing, if you're running a billing service from 25th of the month to the 5th of next month, you can say ballpark that your demand is going to be real high. So you can actually just schedule auto scaling over there, which is manual scaling actually. So schedule that scaling event that I normally operate on 2 or 3 instances, but during this period I want to operate on 10 instances because people are downloading their bills or paying their bills, or there is a billing service that runs on every 25th to 30th that takes up a lot of CPU, all of that. But that comes under scheduling.
Yeah.
Cool. Any other questions, or else we can conclude? Sounds good. Thanks, everyone. Thank you for being a very interactive audience. I hope you have a good weekend ahead. Thanks, Rohan, Aishwarya, for arranging this.
Thank you so much, Omkar, for taking out time to do this. This was very, very insightful.
Thank you.
All right. Cheers. Have a great weekend all.